Quartiles. Quartiles divide the observation in four equal parts when arranged in ascending order of magnitude. Now there are three quartiles, namely quartile 1, quartile 2, quartile 3. Now imagine here is a set of observation given to you. So the first part, when you cut the line here 1, 2 and 3, when you cut it 3 times, the first part here is quartile 1. The part here is quartile 2, and after quartile 2 and between quartile 3 here it is 25% data, it is quartile 3 here. And if you see, the quartiles divide the data into four equal parts. Here is part 1, this is part 2, this is part 3, this is part 4. So three quartiles divides the data into four equal parts. Each part will consist 25% of the value. And remember, here is quartile 2, exactly in between. Quartile 2 is nothing but median. So quartile 1 is a first or lower quartile. Now quartile 1, this part, it is known as first or lower quartile. 25% observation are below quartile 1 and 75% are above quartile 1. If you see this quartile 1, this part carefully, 25% are below it and remaining 25, 25, 25, it is plus, if you add it you get 75. So 75 are above quartile 1. Now when you check for quartile 2, this is quartile 2, so here there is 25% observation, here there is 25% observation, further also there is 25, 25, means 50% below, 50% above, and quartile 2 is nothing but median. Then there is quartile 3, it is also known as upper quartile. Now if you see, 75% observation are below it, so 25, 25, 25, so here is quartile 3 and here there is 75% observation, and 25% observation are above quartile 3. Now we will see the formula for quartiles. When there is raw data given to you, the data will be given to you not in a table form, just random numbers will be given to you. So here the formula is I n plus 1 upon 4. Here why 4 came? Because it divides the data into 4 equal parts, and here I could be 1, 2, 3, that is quartile 1, quartile 2 or quartile 3. The formula for quartiles for group data. Now when some table form will be given to you along with some class intervals or group data, here the formula is L plus H upon F, then open the bracket, in bracket write I into N upon 4 minus CF. Here I could be, depends on the quartile, quartile 1, quartile 2, quartile 3. Now what do you mean by L? L is a lower boundary of ith quartile class. If the quartile class is say 10 to 20, then 10 is the lower limit, that is lower boundary. Now H is nothing but width of the quartile class. If I say the quartile class is 20 to 40, if you subtract both the values you get the width as 20. Then the frequency will be given to you in the table itself. So the frequency which will be there for the quartile class, that will use for F, and CF is the cumulative frequency of the previous class of the quartile, and N is the total number of observation, that is total frequency. Now let's see one example. So here calculate the quartiles for daily wages in rupees by 12 workers. If you see some data is given to you, this is raw data. So first step is to arrange this data into ascending order. So when you arrange, you get the data like this, 170, 180 and so on until 400. Now you have to count the number of data. If you see here, N is 12, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So number of observation is 12. You have to find all the three quartiles. So for quartile 1, the formula is value of 12 plus 1 upon 4 observation. 12 is N plus 1 upon 4. Here I is 1 only, so no need to write here. So when you solve it, 12 plus 1 upon 4, that is 13 upon 4, you get as value of 3.25 observation. Now here see 3.25. So what we will take first, we will split this number into two parts. First we will take 3. So value of third observation plus the remaining part, that is 0.25, that is plus 0.25. And how to select this 0.25? See, value of fourth observation minus value of third observation. How this fourth observation came? Now here we are selecting third, so after third there is fourth, so we'll take value of fourth minus this value of third observation. If you see what is the third observation here, so 1 2 3, it is 190. So value of third observation 190 plus 0.25 into, now value of fourth, so see the value of fourth here, 1 2 3 4, fourth is 200 minus value of third is 190, so 200 minus 190 will give you 10, and when you solve this part you get quartile 1 as 192.5. in the same way we have to solve quartile 2, just one change will be there, that will be here 2 will come because it is quartile 2. So when you solve this, 2 into 12 plus 1 upon 4, you get value of 6.55 observation. So split this number into two equal part, take sixth observation plus 0.5, and in bracket you write one observation ahead of sixth, that is value of seventh observation minus value of sixth observation. So from the previous slide you will get all these numbers. First you have to subtract the value in the bracket, then multiply it by 0.5, and then you have to add the number, so you get quartile 2 as 250. In the same manner we have to solve quartile 3. So when you solve this part you get as value of 9.75th observation, so keep 9 at one place and keep 0.75 at another place, and after 9 there is 10, so write in bracket value of 10th observation minus value of 9th observation. So this is a value which you will get from the values from the previous slide, and when you solve quartile 3 you get 327.5. so this is a simple sum, and such type of questions do come in exam, so you need to just practice such questions thoroughly. Now we will see one more example, and here class intervals are given to you. So the following is a frequency distribution of heights of 200 male adults in a factory. Find the central height. So here is a data given to you for height in centimeters, and here number of males are given to you. So first we will make the table here. Now don't say this red part of quartile 2. First we have to make the table. First write all the heights which is given in the question and write number of males. Now you have to make less than CF, less than cumulative frequency. So here there is 4, so just write here 4. Now 4 plus 6, write 10. 10 plus 25, 35. 35 plus 57, you get 92, and keep on adding the values in the same fashion. You will get here 200. And how you can verify your answer? Add all the number of males, even that is 200, and the last part here is 200, means your addition is proper. So the first part is you have to make this table, and accordingly you can find the central height. Now central height, central means mid value. I have spoken in the earlier slides also that quartile 2 is median. So here we have to find quartile 2, that is central value. So let's start. First, here number of observation n is 200. We have to find quartile 2. So how to find quartile 2 first? 2n upon 4. So 2, the n is 200 upon 4. So 4 ones are 4 50s are. So 2 into 50 you get as 100. Now see, now you have to check the CF. So where 100 will lie? It will lie between 92 and 156. So always take the value which is bigger. Take 156 here and select that particular class as your class interval. So your class interval is 165 to 170. Now here your L will be 165, lower boundary. Your frequency F is 64. Your CF is of previous class, so 156, and above 150, below 156 there is 92. So 92 is your CF. Now just put the formula here of quartile to L plus H upon F 2n upon 4 minus CF. Your L is 165 plus H is width. Width means when you minus 170 and 165 you get 5. So 5 upon 64 into 100 minus 92. This entire value 2n upon 4 you got here only answer as 100. So when you solve it further, it is equal to 165 plus 5 upon 64. Now when you solve this entire part, 100 minus 92 you get as 8. You get the answer as 165.625. So this is your central height, 165.625. This is how you solve the questions regarding quartiles when the values are given to you in grouped form, group data.